The purpose of this webinar is summarized here. Beginning with Release 8.10R3, AOS-specific product lines such as the OmniSwitch 6465 and 6465T models will feature support for the PROFINET protocol. Furthermore, with this release, these models will receive certification from Profibus and PROFINET International Organization. The introduction of PROFINET support marks a strategic step to expand our presence in the industrial automation environment. Let's begin with an introduction to PROFINET, as this may be a new topic for some of you who have not previously worked with industrial networks. Profibus and PROFINET International is the industry association responsible for the development and standardization of industrial communication protocols. PI ensures compatibility and reliable performance across devices from different vendors, supporting digitalization and automation in applications like factory and process automation, motion control, and industrial safety. There are several key technologies that fall under the PI umbrella. Profibus, the original protocol designed for industrial applications, relies on specialized cabling and connectors. Our current lineup doesn't support Profibus since it is based on a different data link layer than Ethernet. PROFINET, this is the focus for us, as it leverages Ethernet technology. PROFINET uses standard ruggedized Ethernet cabling and connectors such as RJ45 and M12, making it compatible with our existing ruggedized product line suitable for harsh environment of a factory, for instance. It is a mechanism to exchange information in real time between controllers and devices in a network. PROFINET is a major protocol used in several industries: automotive, machine building, food and packaging, logistics and process industries. It is claimed to be the communication backbone of Industry 4.0. As you can see, it is a technology for industrial Ethernet. We will explain industrial Ethernet in a coming slide, but let's just shortly mention here that industrial Ethernet covers a series of expansions to the Ethernet standard IEEE 802.3, with which communication suitable for industrial environment is implemented. Another major protocol, which is part of a broader PI technology portfolio that you might run into, is IO-Link, that serves as a sensor actuator interface. It is completely independent of PROFINET, but complements it by enabling seamless integration at the device level. In this webinar, we will focus on PROFINET support on iOS selected nodes and its implementation in industrial networks. Industrial Ethernet shares its foundation with standard Ethernet, meaning many characteristics remain the same. However, industrial Ethernet introduces key enhancements to meet the specific demands of industrial environments, such as real-time communication, robustness, and deterministic performance. Industrial Ethernet, as defined in IEC 61158, supports real-time communication essential for automation and control systems, while 802.3 Ethernet uses the quality of service mechanisms like IEEE 802.1q VLAN tagging and differentiating services in IP networks. It doesn't guarantee hard real-time performance. PROFINET real-time ensures deterministic data transfer by bypassing standard TCP/IP layers, allowing low latency communication with cycle times in the milliseconds range. For even stricter timing requirements, PROFINET isochronous real-time enables precise synchronization by reserving bandwidth and using scheduled transmissions, achieving sub-millisecond cycle times as low as 31.25 microseconds. This is particularly important for motion control applications where jitter must be minimized. The real-time capability ensures reliable communication between sensors, actuators, controllers, and supervisory systems. The IEC 61918 standard outlines guidelines for the physical layer, including cable selection, shielding, grounding, and electromagnetic compatibility considerations, ensuring stable operation in harsh industrial environments. Industrial Ethernet components are built to withstand extreme temperatures, vibrations, humidity, and exposure to electromagnetic interference, making them far more robust than standard office Ethernet. Redundancy mechanisms, such as ring topologies with rapid failover, for instance media redundancy protocol, prevent network failures from causing downtime. Furthermore, error detection and correction mechanisms are integrated into industrial Ethernet protocols, ensuring data integrity even in noisy environment. Industrial Ethernet networks can be easily expanded and adopted to meet the changing needs of manufacturing and automation systems. IEC 61784 defines multiple network topologies, including star, line, ring, and mesh, allowing engineers to design networks that fit specific industrial requirements. Industrial switches support VLANs, quality of service, and traffic prioritization, ensuring optimal performance even as the network grows. Wireless extensions such as Wi-Fi and 5G can be integrated for mobile applications like automated guided vehicles and remote monitoring. Additionally, Power over Ethernet capabilities allow both data and power to be delivered over the same cable, simplifying installation and reducing cost. The IEC 61784 standard defines communication profiles that enable seamless interaction between devices from different manufacturers. Industrial Ethernet protocols, including PROFINET, Ethernet IP, Modbus TCP, follow standardized communication rules, ensuring compatibility between industrial controllers, PLCs, sensors, drives, and human-machine interfaces. This interoperability reduces vendor lock-in and allows factories to mix and match devices to create the most efficient system. Additionally, standardized APIs and OPC unified architecture allow industrial Ethernet to integrate with higher-level IT systems, such as manufacturing execution systems and enterprise resource planning, for real-time production monitoring and optimization. Ensuring safe and continuous operation is critical in industrial environments, and IEC 61784-3 specifies safety protocols like PROFINET safety and CIP safety to protect both machinery and personnel. These safety protocols allow industrial networks to detect failures and immediately put machinery into a safe state, preventing accidents. Network redundancy is another crucial aspect with technologies such as high availability seamless redundancy and parallel redundancy protocol, ensuring uninterrupted communication even if a link or device fails. Automatic reconfiguration mechanisms allow networks to recover from failures within milliseconds, minimizing production downtime. Moreover, security mechanisms such as authentication, encryption, and access control help protect against cyber threats in Industry 4.0 environment. Let's take a look now at the standard PROFINET system and its parts. A PROFINET input-output controller is the central device in a PROFINET network that manages communication with PROFINET I/O devices. PROFINET controller plays a crucial role in real-time control and data exchange within an industrial automation system. Controller performs continuously, reads inputs and writes outputs to and from I/O devices at a predefined cycle time, for instance, every 1 millisecond. This is deterministic communication, and the data is transferred within a guaranteed time window. There is also acyclic communication that is used to configure devices, retrieve diagnostic and status information, or perform device firmware updates. Controller has also capabilities to automatically detect newly connected I/O devices using PROFINET Discovery and Configuration Protocol (DCP), and also assigns IP addresses and PROFINET names to devices, enabling easy integration into the network. We can say it is the brain of a PROFINET network. When talking about controllers, it is usually PLC or PAC or DCS. Then we have PROFINET I/O devices. Devices could be actual robots performing a work on the factory floor, or they could enable communication between the I/O controller and the physical field devices in the industrial environment. I/O devices collect data from the field devices, like temperature sensors or motors, and provide it to the controller. In reverse, they also receive control signals from the controller and act accordingly. For example, activating a valve or starting a motor. The third part of the system is I/O supervisor, playing an essential role in managing, configuring, and monitoring the PROFINET devices and network as a whole. It interacts primarily with the I/O controller, facilitating network communication, management, and configuration. It is used for network commissioning, management, and diagnostics of network controllers and devices, ensuring all components of a PROFINET system are properly connected, functioning, and able to exchange data. It is common to have I/O supervisor and I/O controller roles in a single device. PROFINET I/O controllers, supervisors, and devices will be using the Ethernet network backbone for communication between each other. A dedicated Ethernet switch in this PROFINET industrial network has properties of a PROFINET I/O device in terms of configuration and displaying in the network, but will also support automation-related diagnostic functions of an I/O controller. Acting as an I/O device, the switch can send network errors and alarms of links connected to I/O field devices going up or down. We have mentioned time-critical and non-time-critical communication in PROFINET networks. Time-critical communication is used for exchanging process data between controllers and devices, while non-time-critical communication is primarily used for tasks like configuration, diagnostics, and network monitoring. Let's take a closer look at how these types of communication work in PROFINET. Non-real-time communication in PROFINET is used for configuration of I/O devices and on-demand communication, such as diagnostics. Since this type of communication is not time-critical, it operates asynchronously and uses TCP/IP or UDP/IP for data transfer. As shown in the collapsed OSI layer model, NRT communication follows the standard Ethernet networking stack, including encapsulation and decapsulation through Ethernet, IP, TCP or UDP, and PROFINET data layers, leading to variable delays caused by encapsulation and decapsulation processes. For time-critical communication, PROFINET shifts to cyclic data exchange, where data is transmitted within a specific time frame, ensuring consistent communication between sender and receiver. The cycle time can range from 250 microseconds to 512 milliseconds for real-time communication and can go as low as 31.25 microseconds for isochronous real-time communication. If a data packet does not arrive within the configured monitoring time, the receiving device generates an error message, signaling a communication failure to the application. This time-critical communication bypasses standard OSI layers, jumping directly from the Ethernet layer to the application layer with PROFINET data. This eliminates unpredictable delays in encapsulation and decapsulation of transport and IP layers. This direct communication path is triggered by a specific Ether type, which defines PROFINET's real-time data exchange. PROFINET cyclic data communication is further categorized into two categories. The first one is real-time communication, suitable for standard industrial automation applications, and achievable using standard Ethernet hardware and the PROFINET software stack. Isochronous real-time communication has stricter timing and jitter requirements. The IRT requires additional quality of service mechanisms, including bandwidth reservation, scheduling, and synchronization. IRT is essential for high-precision applications such as printing, packaging machines, and motion control systems. IRT requires specialized ASIC with hardware support for PROFINET to meet the timing constraints. Our implementation of PROFINET on 6465 and 6465T models will support non-real-time and real-time communication. Now let's explore how OmniSwitch supports the PROFINET protocol and how it fits into the PROFINET systems we have just discussed. So why the 6465 series? In short, they are designed and built for industrial Ethernet and industrial applications. You're likely familiar with the key strengths of our 6465 product line, but here is a quick summary as a reminder. The 6465 series are built to thrive in demanding as well as harsh environments like industrial factory networks with both indoor and outdoor deployments. The switches come in fully hardened or extended temperature models with multiple configurations to suit various needs. The 6465 series also enhances capacity, redundancy, and resiliency through virtual chassis deployment. The switches provide power over Ethernet with up to 60 watts, ideal for powering devices like IoT equipment in industrial settings. The 6465 supports IEEE 1588 version 2, peer-to-peer, and end-to-end transparent clock, critical for synchronization in industrial environments. These models include MACsec protocol support, ensuring strong encryption of network data. Positioned in the network, the 6465s deliver advanced Layer 2 services, Layer 3 routing, and support for protocols such as ERP and MRP. These protocols enable loop avoidance in ring topologies, a standard approach for achieving redundancy without extra cabling or infrastructure. For more details of the features and capacities of the 6465 models, please refer to the latest data sheets available on the ALE website. However, it is clear that these product lines are designed for industrial Ethernet, making PROFINET protocol support a natural and valuable next step. In this slide, you can see the overview of the key characteristics of PROFINET support in OmniSwitch. First, OmniSwitch functions as a managed switch node within the PROFINET network, facilitating bidirectional communication between input-output controllers, input-output devices, and field devices. Every node in a PROFINET network must be certified by Profibus and PROFINET International Organization into one of the three conformance classes, A, B, or C. OmniSwitch is certified as a Class B device, and in the next few minutes we will explore what this means and which protocols and mechanisms a device must support to achieve B certification. I want to emphasize that all models from the OmniSwitch 6465 and 6465T product lines fully support the PROFINET protocol. Lastly, but just as importantly, OmniSwitch supports the PROFINET discovery and configuration protocol, enabling efficient device discovery, IP assignment, and configuration within PROFINET networks. All the mentioned features become available once the PROFINET Debian package is installed on the 6465 switch. In a PROFINET network, switches can be either unmanaged or managed, both of which are viable options. OmniSwitches will act as a managed switches. An unmanaged switch primarily provides 100 meg or 1 gig links between input-output controllers, devices, and supervisors. It also ensures prioritization of PROFINET real-time data using 802.1p priority tagging to maintain deterministic communication. However, a managed switch offers additional functionalities beyond those of an unmanaged switch. Those functionalities are simple network management protocol, allowing the switch to provide diagnostics to the PROFINET supervisor upon request. To enable this, a PROFINET management information base has been integrated to support PROFINET-specific features. Link layer discovery protocol for neighbor detection, which provides key network information such as chassis ID, port ID, TTL, port status, interface MAC address, and others. This info is used to provide a topology visualization. By supporting HTTP protocol, web-based management is enabled through supervisor interfaces for easier monitoring and configuration. The goal of conformance classes is to define the standard and optional functionalities that a selected PROFINET device must support. This ensures that two devices certified for the same class provide interoperability, at least concerning standard features. As you can see, there are three classes, A, B, and C. These classes build upon one another. Class A enables basic PROFINET communication, supporting a cyclic communication for parameter data. It also includes cyclic real-time communication, device identification, and topology information through LLDP and device ID. Devices in this category are suitable for infrastructure and building automation applications. Class B, which includes OmniSwitch 6465 and 6465T models, integrate switches into the PROFINET network as input-output devices. This allows for comprehensive network diagnostics from the controller via PROFINET mechanisms. A few optional functionalities, such as MRP support and data timestamping, are planned for future releases. Typical applications for these devices include factory and process automation. Class C applies to devices that support isochronous real-time communication, including hardware support for bandwidth reservation and synchronization. This certification is required for devices participating in motion control applications. One of the features supported by AOS is Discovery and Basic Configuration Protocol, or DCP. This protocol is integrated into various engineering and diagnostic tools, as well as controllers, and is used to discover all PROFINET devices in the network. It allows assigning names and IP address to device during commissioning, setting information on device, and retrieving information from it. One of the examples is the DCP Identify All request, which enables browsing the network for PROFINET devices using multicast communication. Upon receiving this request, input-output devices such as OmniSwitch will respond with information including device name, IP address, subnet mask, MAC address, and device type to the controller. This allows the controller to identify each device and verify its IP address and name before parameterization. DCP protocol also enables easy replacement, allowing a faulty configured input-output device to be swapped with a new one without manual reconfiguration. This feature works in conjunction with LLDP, Link Layer Discovery Protocol. The replacement process operates as follows. The input-output device receives an LLDP frame from its neighboring device. Based on the chassis ID in the LLDP TLV structure, the input-output device constructs an alias name, which is also recognized by the input-output controller. When the original configured device is replaced, the network connection is lost. The new device initially has an out-of-box configuration, but upon connecting to the network, it reconstructs its alias name using LLDP information from its neighbor. Since the controller cannot establish a connection using the original configured name, it instead uses the alias name during the identification sequence. The input-output controller then reconfigures the input-output device, setting the name and IP address using DCP protocol. This mechanism ensures seamless device replacement and minimizes downtime in industrial networks. After discovery and basic configuration, the switch requires additional details to be fully configured for PROFINET. This is done through GSD-ML, or General Station Description Markup Language file. The GSD-ML file describes the input-output device and its properties. It must be integrated into an engineering station to configure the connection between the input-output controller and the input-output device. Each GSD-ML file consists of two main sections. The first one is header, containing general information about the GSD-ML file, including its profile details. The second one is body, providing a detailed description of the input-output device, including identification, integration, performance characteristics, as well as modules and submodules. Once the GSDML file is read into the engineering tool, the field device can be fully configured. The GSD file provides a structured description of the ALE switch as a PROFINET device, and it is modeled as follows. Switch chassis is identified as PROFINET slot. Switch slot is identified as PROFINET module, and switch port is identified as PROFINET submodule or subslot. We will release a GSD file bundled with the PROFINET Debian package. When the PROFINET Debian package is installed on the switch, one has to copy the zip file containing the GSD ML description to flash/switch directory, and there is no need to extract the zip file. The file has a zip format as it contains the main file in XML format and graphic file in BMP format. There are two ways to upload the GSD file to the supervisor tool or controller. One can download the file directly from the ALE website and install it in the tool or controller, or upload the file to the tool directly from the switch itself. How to configure and deploy the switch for the PROFINET network. The first step would be to load PROFINET Debian package to flash/working/package folder and install it. Good practice is to check whether the package is installed successfully using show package manager command. By default, a PROFINET VLAN would be VLAN 1, but it can be easily changed using PROFINET VLAN command. Upon configuring a PROFINET VLAN that will be used for PROFINET communication, the switch ports have to be added to that VLAN. Once ports are assigned to the PROFINET VLAN, be aware that internally all ports are made COS trusted ports. The admin status of PROFINET will control whether PROFINET functionality is active or not. There are some other PROFINET parameters that are not configurable through CLI or WebView or through SNMP, but via DCP messages from input-output controller. These parameters can be checked using show PROFINET status command. Show PROFINET session command will display switch established sessions with controller and supervisor. As we approach the end of this webinar, here is a quick reminder about industrial network architecture. For medium and large industrial networks, a fundamental design principle is separating the enterprise network IT and the production network OT into logically isolated zones. This ensures security, performance optimization, and operational stability. Communication between these two zones is managed through redundantly deployed firewalls, ensuring controlled data exchange while preventing unauthorized access. The most common network topology in industrial environments is a ring structure, as it provides a balance between cost, performance, and reliability. Other topologies, such as star or linear, are possible, but are less common due to their limitations in redundancy. To maintain high availability, standardized redundancy protocols such as Ethernet ring protection or media redundancy protocol are used in the ring topology. When implemented according to industry standards, this ensures fast network recovery times, typically below 50 milliseconds. Whether using a two-tier or three-tier architecture that includes a distribution layer, high availability and reliability are essential to prevent downtime and ensure continuous operation. With the introduction of PROFINET protocol support on our selected network switches, we take a significant step forward in addressing the needs of industrial environments. PROFINET is recognized as a leading industrial communication protocol, widely adopted for its reliability, deterministic performance, and real-time capabilities. By enabling PROFINET on OmniSwitch 6465 and 6465T portfolio, we strengthen our position within the industrial networks segment, offering a robust and competitive solution tailored to the evolving demands of Industry 4.0. This support provides customers with a seamless integration path between IT and OT domains, enhancing operational efficiency and control. This new capability not only broadens the applicability of AOS switches, but also delivers a clear competitive advantage in the industrial networking market.